All right, so we are thinking here about continuing our exploration into classifying triangles specifically. And so when we think about triangles, we have gone through and we recognize that you can classify them or sort of group them or make a statement about them based on their sides and based on their angles. You can down here classify triangles. So triangles can be classified by the length of their sides and by the measure of their angles. And this is kind of cool because this next part is that it is possible for angles to be classified using two terms, right? As long as one term describes the angles and one describes the sides. Oops, this is supposed to say it's possible for triangles to be classified using triangles, not for angles, triangles, um, using two things. So you can say, I have an isosceles right triangle, right? Or draw an isosceles right triangle. And in that case, you might draw a right triangle, and this side are the same length, right? Even if they don't exactly look like it, by marking it like this, saying that they're each a one hash mark long side length, then we know they are the same. Isosceles has two sides the same length, and it has one right angle. So you can have, an equilateral acute triangle. You can have a scalene obtuse triangle. You can classify them by their sides and their angles to be more specific. So you get to draw an example of an obtuse isosceles triangle here. I'll look forward to seeing what you come up with. So then you can come down here and try it again. So down here it says draw an acute right triangle. Okay. So an acute right triangle would be classifying by angles twice, acute and right. And in that case, it is not going to be possible. And let's dig into that a little bit. So if we think about an acute triangle, we might say this is an example of an acute triangle. All of the angles are less than 90 degrees. In a right triangle, you have to have one that is 90 degrees, right? You have to have an angle that's 90 degrees, meaning it is obviously not less than 90 if it is 90. So this is not possible. Could you change one of these features? Either the right part or the acute part to make it true? Well, sure, you could say, I'm going to end up making um, a isosceles right triangle, right? Like we did up here. So you can make an isosceles right triangle. If you classify by sides and angles, then you can have two descriptors. But if you try to classify by angles twice, you're going to run into an issue like we did here. Down here, you get to try this one. You can draw a scalene triangle. You might want to remember what scalene means. If you have all of your sides sort of being different, you might end up leaning, right? So a scalene has no congruent side lengths. Nothing to do with the angles here. You could sort of push yourself to include a statement about the angles, but you only need to have a scalene triangle. All right, so good luck and have some